All right. Where are we here? Oh my goodness. It's the 20th already. I feel like I say that every day. They're gonna fly by. I know, right? Everyone got a practice test? Right? Yeah, I think so. So make sure, just like the other 2 practice tests, if you do it for completion marks, I'll check it at the beginning of the review class. If you have to choose, then I really don't care about the short answers. It's the long answers that I'm looking at, okay? So, and I'm gonna be a little bit stricter this time to get the completion mark. I wanna see timelines, at least for the long answer questions, okay? Bare minimum, all the timelines for the long answer for that completion mark. Okay. So we're gonna do it on Thursday, right? So you don't have a ton of time, but like I said, don't worry about those short answers. They're really just there to give you an idea of the length, right? And what you'll find is that it is quite long. Okay? And that's why for these short answers, I've just given you the slots to fill in with your calculator information, because you will want to use your calculator for well, wherever I'm giving you the slots, you'll want to use your calculator to solve those. Okay? So otherwise it'll take way too long. Thursday. I know. Cracking the whip. But just completion marks, I don't care if it's right. I just care that you tried. That's all I care about. Okay. There's also a Moodle assignment posted. I think it was, I must have posted it last week on Wednesday or Thursday, but it was supposed to be due Thursday at midnight. How about we make it Friday at midnight? Is that better? All right. Great. So, do practice test number 3. For completion marks. No audio. Okay. I'm not on. Let's see here. It's echoing on my end. Let's see here. Anyone else having audio issues? Anyways, we'll see. Anyways. Oh. What does that mean? I know, but I don't get it. It's too young. Too young, too hip and happening for me. Is that better, Kevin? Okay. All right. For completion marks, at the beginning of class, has to be at the beginning because we'll go through it together on Thursday. It's my last one. I stopped printing the right amount, so now I just do a gamble every time. Like, oh, 27 should be enough. I don't know. Otherwise, I just have tons of paper. Okay. And Moodle assignment, can't remember what number assignment 4. I'm moving it to Friday at midnight. It's actually a little bit before midnight, but whatever. It's 5 questions. There's a lot of work behind those questions, right? But you can do it. 5 Moodle questions. Not too bad. Oh yeah, just ignore the Moodle. Moodle's not, I haven't set it up because it's not very clever to begin with. Assignments are worth 15%, I think. Yeah, but these completion marks that we do for the practice tests are counting as assignments as well. So, okay. We won't be able to do, I'm not doing any written assignments before test 2. I know, right? Mostly because I won't have time to mark them. That's a problem. So we will do a last written assignment for mortgages because that I will have time to mark. But besides that, just one more written assignment coming your way, and then you'll be in the clear. Okay. So today we're gonna finish. Yeah.
Sorry. No? Are we gonna get like some sort of practice test that's like a compilation of all of them for the final?
Oh yeah, I'll give you a practice final just like you get practice tests. Yeah. So not to worry. And we've got 2 days slated for exam review. So that's really good. Yeah, luxurious. So, and remember on the final, the only thing that you won't have been tested on is 8.1 mortgages. But mortgages they're pretty fun. You get a table and you fill it in, and I don't know, it's fun. So it's like, it doesn't even count as work. So we've got our review next class, and then we've got the test on Tuesday, and then we're gonna do mortgages on the Thursday. You're gonna get the assignment for mortgages on the Thursday, and I'm gonna have it due on the Tuesday, right? So usually I give you a week to do it, but you're gonna have just from Thursday to Tuesday to do it. So just kind of give yourself some time to work on it there. I know you'll probably leave it till Monday anyways, so it doesn't matter. But, or if you're anything like me. But just as a heads up, you'll have a short turnaround-ish for that assignment. But then I'll have it back to you on Thursday for the last day of classes. Cool. So, oh, what else? No, let's just get to it. So chapter 7. I can't remember what it's called. Something vague. I remember it because I had to look it up yesterday. I think it's like more annuities or something weird. More on annuities.
Yeah, right? We'll have a good talking to with this guy.
He's just upstairs.
Is he?
Yeah.
Yeah. He works here?
Yeah. He's the head of our department.
Is he really boring?
No. Yeah. It's like,
it's not good at titling stuff.
like, no, he's a friend of mine. That's like a joke. But so 7.1, we're gonna get into annuities due. Okay. 7.2 is on I want to say deferred annuities, can't remember. And then 7.3 is on my favorite thing, perpetuities. So we'll get there. Okay. So only one section on annuities due, but that's because we know all about annuities. Now we've got annuities due, which we know is just the payments are being made at the beginning of the payment period, right? And that's the only change, but we need to make adjustments for that in our calculations, right? Because either if we're making a deposit at the beginning of the month, right, it's going to sit there and earn interest for that whole month instead of being deposited at the end, right? So we need to make adjustments for that. Annuities due. So payments are made at the beginning of the payment period. I know what you're wondering. How can I reflect this in my timeline? Well, what we do is we just shift all our payments over one, right? So usually we have today, and then our first payment is at the 1 month mark or whatever, the 1 week mark, right? Now the first payment is going to be today, and then that last payment, usually we're at the very end tick, right? We're going to move it back one, right? Because beginning of the month or the end of the month, they'll be at essentially the same tick, right? So that's how we're going to show it on our timeline, that we have payments at the beginning of a payment period. Right, so to show this on our timeline, we shift our payments over by one payment period. For example, in a general situation here, if we have today and then 1 period, 2 periods, dot, 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 to n-1 periods and n periods. Right, what I mean by that is that the first payment would be today, and then my payments keep going up until the n-1th period.
Oh, not on the end.
That's right. Just because we used to put it just here, right, at the end of the period, right, boom, 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 right? Now we're shifting everything over one because everything's at the beginning of the month or beginning of the week, beginning of the year, right? So that's how we indicate that. So what happens here is if we're thinking about it in an ordinary annuity situation, right, we would have our future value would go to here, right, to n-1, with the formulas that we've already developed, right? Our formulas go to the last payment, right? And so here we would have a future value, an ordinary annuity, and then we would have to take it this little bit further, right, for 1 period. And so what do? We have a future value times 1 plus I, right, to account for the interest. To account for interest, let's say earned in the last period. So all that's really happening with our, so future value due, right, for an annuity due, that's going to be the same as a future value times 1 plus I, right? Future value for an ordinary annuity. So we know the future value of an ordinary annuity, right, on our formula sheet. So we can replace that and say, okay, well, inside these big brackets, I'll just put the future value of an ordinary annuity. And then all we do is multiply by 1 plus I. Right? And so we have the payment. See if I can copy the right one. Times 1 plus I to the n minus 1 over I times 1 plus I. If you look at your future value due formula, that's exactly what's going on, right? It's just your ordinary future value times 1 plus I, only to account for that last little period of interest. Yeah.
We're timesing the payment by the formula and then that sum by the 1 plus I?
Yeah.
Okay.
Mm-hmm. I know these brackets were throwing people off yesterday. I'll put them as optional brackets. It's just me being little, I don't know, controlling. Exactly. Same thing happens for the present value, right? You just take your ordinary present value and then you have to multiply it by 1 plus I. If you look at the n formulas, right, they look very similar, except that the 1 plus I is in that denominator now. And the reason for that is, so if we have something like in n, or in the formula for n, in the formulas for n, we have 1 plus I, oops, in the sort of denominator, in the first denominator. We'll call it the denominator. You'll see it. That's because we've got the future value due is the future value times 1 plus I. We'll just look at the future value, and then the present value behaves the same way, right? So in our ordinary annuity, we've just got our future value in there, right? And so if we solve this for our future value, right, it becomes the future value is the future value due divided by 1 plus I, right? So we replace the future value with future value due over 1 plus I, and that's how the 1 plus I ended up in that denominator there. I don't want you to worry too much about what's going on here if it doesn't quite make sense. As long as you're comfortable picking out the right formulas and using them, that's all I care about, right? It's just sometimes it's helpful to know that these aren't as bad as they look, right? You will have this one. Yeah, so for the final, it'll be the exact same as the test. You have to use my formula sheets, right? But they're just clean versions of the ones that you have. So you'll know exactly what to expect to have on the formula sheet. Cool. So, let's get this. How about we do an example? Let's do example 224. Oh, I gotta steal it. 224. Oops. Okay. So from last day, right, we said we have to keep track of what our compounding frequency is and what our payment frequency is, right? So that's the first thing that we look for. Now we're adding a final thing, right? Are the payments being made at the beginning or at the end of a payment period, right? If it's not clear, right, then they're probably at the end, right? So if they're at the beginning, then I'll have to specify these payments are starting today or at the beginning of the month or whatever. Okay? So it should be clear when they're being made at the beginning, right? Anything else is at the end. So let's start highlighting here. So we've got the beginning of the month, of each month, right? So our payment frequency is monthly, and we're compounding quarterly. I guess I should read the question. Yeah, like, woo, I see it. Payments of $350 are made at the beginning of each month toward a car. What a surprise. What is the car worth if payments continue for 5 years and money earns 4% per year compounded quarterly, right? What's the car worth, right? That's going to be the present value, right? Because if you're paying it off with payments, right, then you've got some loan amount, essentially, right? And that's what the car is worth. So whenever I ask you, how much is this worth? That's going to be a present value, right? If it's a loan situation, right? If you're making contributions and you're saving, then you'll want to know the future value. So let's see here. I'm going to start by jotting down just some quick notes, right? Those 3 things that we highlighted, right? And the notation that we're going to use is, so the beginning means it's an annuity due. The notation that we'll use is just BGN. And I'm stealing that from your calculator because of course we can change our calculator to say, whoa, these payments are actually at the beginning, right? And so the calculator function is BGN. Okay? And we'll talk about that in a bit. So then I'm gonna say, okay, well, my payment frequency, so payments per year, is monthly, so 12. And my compounding frequency, my compoundings per year is quarterly, so 4. Okay. These aren't the same. So first thing we have to do is we have to adjust our compounding frequency to match our payment frequency, right? And so because we're moving from a compounding frequency of 4 to 12, that makes this F1 and this F2, okay? And this will always be the case, right? Your compounding frequency is going to be your F1, and your payment frequency is always going to be F2. In our I2 formula, right, we need to know F1 and F2. So that's always going to be the case. Okay. So, and even for these kind of trickier questions where you'll want to use your calculator, right, or / need to use your calculator, I still want to see the calculation for I2, just because I just want to know that you know to do it and how to do it. So even if you don't have to use it, I still want to see it. So we've got the rate is 0.04. So I1 must be R1 over F1, 0.04 over 4, a nice tidy 0.01. So I'm going to calculate I2. Which is 1 plus I1 to the power of F1 over F2 minus 1. And this is what I mean by, we spent that kind of part of a day talking about effective rates and how to change to different frequencies, but really this I2 is the only one that you need. The others will show up in short answer questions, right? What's the effective rate of this? Blah, 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 right? But at the end of the day, this is the only one that you really need to use in your calculations. So here we've got 1 plus 0.01 to the power of F1, which is 4 over 12 minus 1. 1.01 to the power of, and I put my 4 over 12 in brackets just to make sure, so 4 divided by 12 and brackets, minus 1. I get an I2 of 0.003322284. I'm going to store this in 1. Of course, we'll need it later, so may as well store it. Okay. Now that we've got that part done, let's do the fun part, see the timeline. Right. Now that we're getting good at these timelines, I think they're pretty fun. Okay, so starting today, we're making payments at the beginning of each month. For how long? For 5 years. So we're gonna start today. And we're making payments for 5 years. So we've got 1 month, 2 months. How many months in 5 years? 5 times 12, 60. 60 months. So this must be 59 months. Dun, dun. Great, so we're making payments of $350 starting today, right? Because that's the beginning of the month. $350, $350, $350. And then our last payment would be the 59 months. So, I don't know. There's someone talking in here. In here. It's in the computer. Oh. You guys have seen Zoolander, right? Come on. So these, right, they're paying off some present value, right? So I'm going to highlight, okay, so I'm going to take this back to today, and it's going to be some present value due. And that's what I want to find, right? Because that's the value of the loan and thus the car, right? So here I've got my N is time times the frequency. N for annuities is the number of payments, right? Which we actually had to find already, right? So it's going to be 5 times 12, which is 60. So now we can find our present value due. We can use our formula sheet. It's the payment times 1 minus 1 plus I to the negative n over I times 1 plus I. All these I's are going to take up a lot of room, so I should have moved it over a little bit, but oh well. See if I can cram it in. So our payment amount is $350 times 1 minus 1 plus I. Just like before, right, we're going to use our I2 as our I. And so we've got 1.003322284 to the negative 60 over 0.003322284 times 1 plus 0.003322284. Eek. Snuck it in. Because this is our kind of warm-up question, I'll write out what those big brackets are, but usually I'll just go right to the end, right? Because it's hard to kind of stop and write down our work when we're on a roll. And so we've got 1 plus recall 1 to the power of 60 negative equals 1 minus that, right? Remember, it's 1 minus whatever you found. And then divide that by recall 1. Okay. So I get 350 times 54.31671541 times, oh, what's going on here? 1.0033222284. I guess I'll store that in 2 for a bit. So then I've got 1 plus recall 1 times recall 2 times 350. 19,074.00983. The value of the car is $19,074.01. Steal of a deal. Depends on the car.
2001
Oh yeah. Going. So, like I said, of course we can do this on our calculator, right? And so we just need to be able to set the mode for either beginning or at the end, right? The default is that the payments are being made at the end of the payment period, right? And so if you look at your calculator, above the PMT button, you've got BGN in yellow, right? So what you're gonna do is you're gonna hit second payment, I guess, to get into that begin menu. And it should just say end, right? If you hit second enter, it should say begin. Right? And so what you'll notice up here at the top, in kind of the top strip, is that you've got BGN as a reminder there. So even when you exit out of this, so go second quit, it'll still say BGN up at the top there. Right, so just make sure that that's what's going on. No? Yeah. 50-50 split. Okay. So you're gonna go second payment to get to the begin menu, and then second enter to change between the modes. Okay. And then you can just go second compute or quit to get back to the main screen. Got it? Everyone got it? Okay, cool. So to calculate annuities due using the TVM, time value money functions of our calculator, on our calculator, we need to change the mode to BGN. I guess from end, right? This is the default. So to do that, you're gonna hit second PMT button to get to the yellow BGN menu. And then to change modes, hit second enter. And then the screen will show the mode. Cool. So make sure that's working. So that means that we're gonna have one last little piece of information if we're doing things on our calculator, right, to show our work. We have to show whether we're in the beginning or in the end mode, right? And so that's why it's, oh, I don't have copies of your practice test, but you all do, right? That's the last piece of information on the calculator strip, let's call it, I don't know, that you have to fill in. Right? And actually, what I would do if I was doing those short answers is I would fill in all the calculator information, right? And then change my mode to beginning, do all the beginning ones, and then change my mode to end, and then do all the end ones, just so you don't have to flip back and forth. It really doesn't matter. That's just me being lazy, but that's what I would do. So let's do, which example? 224, I think. Let's do that one on our calculator. So example 224 on our calculator. Right. It's nice when we know the answer, we can make sure that we're doing it right on the calculator. So we have to have our N, our interest per year, our present value, our payment amount, our future value, our payments per year, our compoundings per year, and beginning or end. Oh, and I want to say too, in case I forgot to say it on the review day, for the test, for test 3, I'll give you that strip of calculator inputs, okay? And so even if you just fill it in, that'll be worth part marks, right? So knowing how to fill those in is worth something to me. So even if you just fill it in, I can give you part marks, right? So that's handy. All right, so we've got an end. We've got 60 payments. Our interest per year was 4. We want to solve for the present value. Right, so I'll just put a star there. We'll temporarily put in 0 and then we'll go back and compute it. Our payments are negative 350, right? Because we're paying off this loan, so it has to be negative. The future value, once we've paid off a loan, the value of that loan should be 0, right? So the future value is going to be 0. Our payments per year, we said, was 12, and our compoundings per year was 4, and beginning. So if we go ahead and plug these in, make sure you're in the beginning mode, and then 60 and 4 for interest per year, 0 for the present value for now, 350 negative for the payment, 0 for the future value. Payments per year is 12, which I already had conveniently. Compoundings per year is 4, enter, quit. And then compute the present value. I get 19,074. 0.00983. Nice. Just for kicks, what if we changed it to the end mode? So I'm gonna go in there and I'm gonna change my to end. Then I'm gonna compute the present value again. I get $19,010.85. Mm-hmm. So if these payments were being made at the end of each month, that's what we're talking about, right? Then the value would be $19,010.85. Just changing the mode. So if we left the calculator in end mode, we would find that the present value is $19,010.85, which would be wrong. So you have to be careful because it does make not a huge difference, but it does make a difference. Okay. How about another example? 225. Oh, better start over here. Got a little wonky. You purchase a car worth $25,000 by making beginning of the month. So let's highlight that. Right, so these payments are at the beginning and the payment frequency is monthly. Payments of $375 for 3 years and one final payment at 3 years for the remaining amount. That's kind of weird. We haven't really seen that before. If money earns 7.5% compounded semi-annually, what is the final payment? So for this, we have to use our calculator. We can do it by hand, but I would expect to see it just on your calculator because I'll show you it's easy to do on your calculator. Okay. But first we have to figure out, okay, what's going on here? So we purchase a car for $25,000, right? So we get a loan of $25,000, right? And then we're making payments, right? Kind of eating away at that amount. But at 3 years, we're not done paying it off, right? We're going to pay some lump sum to pay it off. But we also know that even though we got $25,000, what we're paying back is going to be a lot more than $25,000, right? So we have to adjust for how much interest we owe on that $25,000, right? And so what happens, first let's jot down our information and then we'll draw it out as a timeline, okay? Because we've got this loan amount, we're making payments to pay it off, right? And then we want to pay a lump sum to square it all up at 3 years. Right? So first let's make some notes. We want to be in the beginning mode. Okay. I'll jot down my payments per year is monthly, so 12 again. And my compoundings per year is semi-annually, so 2. Just like before, our payments per year is going to be our F2 and our compoundings per year is going to be our F1. Because these aren't the same, we're going to have to find I2. And so, which means we have to find I1. So R1 is, what was it, 0.075. So I1 is R1 over F1, 0.075 over 2 Oops. .0375. I'm not going to try to be a hero up here. Like more than 2 decimal places? No. So I2 then. I2 is 1 plus I1 to the power of F1 over F2 minus 1. If you want to play it safe, as soon as you have an annuity, calculate I2, right? Or try to, because you'll quickly figure out that, oh, F1 and F2 are the same, so I don't need to do it, right? But it's good to get in the habit of trying to always find I2, and then if you don't have to, then that's better than not doing it when you should have done it, right? So we've got 1 plus 0.0375 to the power of F1, which is 2 over 12 minus 1. I get 1.0375 to the power of 2 over 12 in bracket minus 1. 0.006154 524.
Is finding I2 like part of our timeline now?
Yeah.
Yeah. Okay.
Yeah, so I will make you find I2 as part of your complete timeline. And that's because if you're using your calculator, then I want you to have to do as much work as someone who's doing it by hand, right? So just to make it fair, you have to show your I2 even if you're just doing it on your calculator. Okay? I'll store this in 1, even though I won't use it, because I'm about to use my calculator. Okay? So what does this look like as a timeline? So we said, okay, we're making beginning of the month payments of $375. So I'm going to start today and go for 3 years. Today for 3 years. And I'm making monthly payments, so 1 month, 2 months. 3 years has 36 months, 35 months. I'm making beginning of the month payments of $375. So I start today and then make payments until the 35th month. I did find one.
350.
Okay. Another one. We'll march it upstairs.
Yeah.
He'll be like, well, you can all read, right?
Not clear enough.
So, right, these at 3 years will have paid off some amount, right? So that'll all be cleared up because we've been making payments to pay off this $25,000. Right? And so the remainder, the remainder that we have to pay, right, is going to be the difference between the $25,000 with interest and the payments that we've already made, right? And so we've got this here. These payments are going to keep going and become some future value due at 3 years. Right. Plus some remaining payment that's going to add up to this 25,000 that we got today. That's just going to sit there for 3 years, become some future value. Let's call it future value total. We could do this by hand, of course, right? Because here, this is just back to normal compound interest, right? There's no payments, no regular payments. And so we can just take this 25,000 for 3 years, right? We would have to use we don't have to, but we would want to use our new I2, right? Which means our compounding frequency is now 12, right? So when we have to find our number of compounds, it would be monthly, right? So that's a little bit of a pickle, right? But our calculator can just do this for us, right? Because we're saying, okay, well, I got a loan amount of 25,000, right? But then I'm going to be making payments at the beginning of each month of 375 at 3 years, right? After 36 payments, the future value is however much I've got left owing, right? So on our calculator, we've got N, we've got interest per year, we've got our present value, our payment amount, our future value, payments per year, compoundings per year, and beginning or end. So we're going to make 36 payments. We already know that. Our interest per year was 7.5. The present value is the 25,000, so the amount that we got, the loan amount. Positive. Loan amount we got. Right, so it's positive. Then we're making payments of 375. We make payments, right? So that's why it's negative. We want to solve for the future value because this is the remaining payment. Remaining payment at 3 years. Payments per year was 12, the compoundings per year was 2, and we're at the beginning. So, okay. 36, 7.5, 25,000 positive, present value 375 negative, payment 0 for future value for now, 12 and 2, enter. Make sure you're in beginning mode and then compute your future value. I get negative 16,025.98. Oops, should have given myself more room. 771. So at 3 years, we would need to pay 16,025 and 99 pennies. And it's negative because we would have to pay it, right? Is a lot of money. Okay. But so for these types of questions, right, you'll want to use your calculator, right? You can do it by hand, but it's a lot more work. Yeah.
Which one is that?
That's going to be this remaining payment. So we don't actually get to see what the future value due or what the future value total are. We're just trying to find out what's the remaining payment is that future value that we found. Cool. Say that again. No, just me being sloppy. N is time times the frequency. 3 times 12, which is 36. Marks off. That's right. Okay. Let's do example 227. Oops. Susie takes out a loan of $20,000 so that she can purchase a new car. Again, what a surprise. Can you tell the most common loan situation? Car loans. She intends to pay this back with $175 installments at the beginning of each week. So let's just highlight what information's coming in here at the beginning of each week, right? That's our payments. Assuming the bank charges a rate of interest of 3.5% compounded annually on her loan, how long will it take for her to repay her debt? Right? So how long is it going to take? That means that we need to find time, but to find time, we first have to find how many payments she has to make, and then we can figure out how long it's actually going to take, right? Because if someone asks you, oh, how long is it going to take? And you said it would take her 200 payments. That wouldn't fly. So we have to find out how long is it going to take in years. Okay. So again, we've got a beginning situation. Let's jot down our payments per year and our compoundings per year. Our payments per year is going to be 52, right? Weekly payments. And compounding annually, just 1. R1 is 0.035, and I1 is R1 over F1. Oh, and F1, of course, is the compoundings per year, and F2 is the payments per year, just like before. Okay. So 0.035, here comes my most redundant weakness. There. I still show all my work, even if I'm dividing by 1. I just can't shake it. 0.035. Yeah. So because 1 is not the same as 52, we have to show our I2. And so I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.035 to the power of 1 over 52 minus 1. 1.035 to the power of 1 over 52 minus 1. I get 0.00066175. I'll store this in 1. Okay. So now we can do our timeline. Right. I don't know about you guys, but these ones where we don't know how long it's going to take, they kind of weird me out a little bit, right? Because we just have to know, okay, well, we're just gonna make n payments, I guess, right? So we go from today. We know she's gonna make beginning of the week payments. So 1 week, 2 weeks, oops. And then n weeks, and minus 1 weeks. Payments of 175. 175 at the beginning of each week. So the last one is at n minus 1 weeks. She's paying off a loan of how much? 20,000, I think? Yeah. And so she got 20,000 today, right, to buy this car. And so the present value that we know is 20,000. Okay. I'm still gonna say that this is gonna be worth, this is the present value due equals 20,000. Just to highlight that, okay, we know the present value due. Right? And n equals question mark. Right? So to figure out how long is it going to take, right? We first have to find n, how many payments do we need, and then we can find t. So, all right. We have a formula for n. Oh, I'll scoot it way over to the side of the page because just having a peek here at our formula, right, it's going to be kind of long. Lots of I's in there. I's are long. And we know our present value due, right? So that's the n formula that we have to use. So we've got negative log of 1 minus I times the present value due over the PMT times 1 plus I. All over the log of 1 plus I. How I calculate these, right, because it's going to be a lot of bad math going on, right? I start here, and then, so find 1 plus I, and then I multiply by the payment, right? Then this part is simplified. Then I do this divided by this, and then I can multiply by I, and then I can subtract that from 1. Right, so I just kind of snowball out from that 1 plus I. Yes. Yeah. Once you found have found I2, that's the I that you're always going to use. Okay, let's plug these in. We've got the negative log of 1 minus I, which was 0.000661785. Shouldn't have written so big there. Yikes. Times, I'll put it in brackets, my present value due, which is 20,000, over my payment amount, which is 175 times 1 plus I, which is 0.000661785. Yep. I'm only throwing on these brackets just so I can keep track of, I have to find this first before I don't have to, but I'm going to find that first before I can multiply by it. All over the log of 1 plus 0.000661785. Are you not glad that you know the store function? Or what? So I'm going to start with 1 plus recall 1 times 175. I'll store that in 2 for now. Because then I want to do 20,000 divided by that guy times recall 1. 1 minus that. Okay. So I'll just pause here. You don't have to, but just so you can check your work. I get the negative log of 0.9244174773 all over the log of 0.000661785. So just do the log. So once you have that 0.9244 on your screen, just hit the log button. What you'll find is that you get a negative number, and that's the only reason that that negative is out front, right? Because we can't make negative payments, so we have to cancel out that negative, right? And so technically we have negative 0.0785914999 over, we'll store that somewhere. 1 plus recall 1. Log of that. 0.0006661566. Recall 3 negative divided by that answer. I did it wrong. Okay. I get 118.7961759. I got 1759. So we're good. As long as you got the 118.7961759, you did it. Okay. So how many payments would we need? We would need 119 payments, right? Regardless of what the decimal is, we always have to round up to a whole number, right? So even if it was 118.01, you would still have to make 119 payments to pay it off completely, right? So we would need to make n equal to 119 payments. N is time times the frequency, right? Where F is still the payment frequency. So 119, which makes sense, right? We've got 119 payments, and then we want to divide it by the payment frequency, right, to get the time. So it's time times the payment frequency of 52, I think, right? So time is 119 divided by 52. Time 2.28846153.8, or roughly 2.29 years. You don't have to convert to years and months or anything like that, right? Just leave your time as a decimal. It would take approximately 2.29 years. Nice. Any questions about that one? So that's annuities due. What about 7.2 is on deferred annuities? A deferral, right, is when you put off making payments or even getting payments, right, for some amount of time, right? And so we need to know how to deal with that, right, for our payment structures, etc. Okay. So this is when the payments are delayed, we have a deferred annuity. So let's see here. I used to do a general example, but it might just be easier to just do an example and show you what's going on, right? Because sometimes these general things are kind of hard to wrap our heads around. Okay, so let's do example 228. So today is the beginning of January. Bet you didn't know. Your bank offers you an investment which pays $100 per month for 5 years, beginning in 5 years, right? So they're going to put off making payments for 5 years, and then they'll start giving you $100 each month for 5 years. Okay? So that's going to be a deferred annuity. With the first payment at the end of January. So if money earns a rate of return of 3% interest per year compounded biweekly, what is the most that you should pay for this investment? So they're asking you to pay some amount today, right? And then they're promising to give you $100 each week for 5 years in 5 years. I find it kind of confusing to have 5 and 5. So what we'll do is let's make it beginning in 4 years, right? Just so we can keep track of these. Okay. Let's say here, beginning in 5 or 4 years. On test, no. But because I'm just showing a concept here. You could just learn one question really well and just write it out for all the questions.
You'd be like, you know what, I don't like your question here.
Yeah.
I'm changing a few things.
And I would probably have to give you part marks. So you could just memorize one that you really like and just write that exact same question for all of them. Yeah, I guess. I will say this, you wouldn't pass the course, but it's worth a shot. Well, maybe learn like 4 that you have in your back pocket that you can just kind of put down, and that should get you a pass.
I'm gonna rewrite this test so that it works for me.
That could actually get you a pass. I'm so curious. Do you remember some key question types? You probably could. It's like, you said compounding biweekly, but I'm going to compound weekly. Okay. Like, as long as you're consistent. Well, as long as you're consistent, don't really dock marks that much. So anyways, that's neither here nor there. It would actually take a lot of work to prepare that, but anyways. All right, so our payments, right, are at the end of January. And so even though today is the beginning of January, that might throw us off, right? But as far as the payments go, they're starting at the end of January, right? So they're actually going to be at the end of the month, right? And so, or is it, yeah, per month. So it's actually at the end, as far as the payments go, right? And we're getting payments monthly, and it's compounded bi-weekly. So it's actually at the end. And our payments per year are 12. And our compoundings per year is bi-weekly, so 26. Because these aren't the same, right? I have to find I2, so I may as well just kind of go ahead. R1 is 0.03. F1, oh, I know F1 is my compoundings per year. Payments per year are my F2. So I1 is R1 over F1, which is 0.03 over 26. Oh, this is going to be some sort of nasty. 0.0011538846. I'm going to store that sucker right now. Okay. How about I2? I2 is 1 plus I1 to the power of F1 over F2 minus 1. One plus 0.0011538846 to the power of 26 over 12 minus 1. That's 1 to the power of 26 over 12 minus 1. 0.00250163. I'll store that in 1. Just because I don't need my other stored one. I've already used it. Okay, so what does the timeline for this look like? Let's see here. So today, we're told is the beginning of January, right? And so we changed the cutoff to be at 4 years. We're going to start getting payments each month for 5 years, right? So 4 years and then for 5 years. So in the grand scheme of the timeline, right, this is at 9 years, but I'm going to put it way up here, right? Because what I want to do is I want to put the number of payments right on top of the tick. So 5 years of payments. That's the tricky part with these deferrals, right? Is that we're only getting payments for 5 years, right? But we are referencing from today, so it gets a little wonky, right? So total 9 years, but 5 years of payments. So 5 is the time that we use for the number of payments. And what's our payment frequency? Monthly. So here we go. I'm just going to do 1 month, 2 months. 5 years sounds familiar. Bless you. 5 times 12. 60 months of payments. 59 months. ... So they're saying we're going to pay you $100 at the end of each month, right? So the first payment would be at the 1 month mark, 2 month mark, 59 months, and 60 months is your last payment. These payments are worth something at 4 years, right? So 4 years from now, they'll be worth something. Right? So this will just be some present value. Let's call it present value 1, because that's the first thing that we're going to calculate. Right? But then we want to know what's the value of this today, right? And so this has to get discounted for 4 years, but there's no payments happening here, so we just use the regular compound interest formulas, right? But now we've got this switch where, okay, well, at 4 years, this is actually going to be a future value, right? If we're talking in terms of today, right? So first we find that present value at 4 years, and then we treat that as our future value after 4 years. Right. So this is going to be some present value 2. What we'll want to do, right, is so here we've got n is 60 payments. Here we've got n is time times the frequency, right, to match the payment frequency, right? Because then we can just use the I2 that we found. We don't have to switch between I's, right? So we're going to use the frequency that we moved to, which is 12. So we've got 4 times 12, which is 48. Just make a note here. Use the new frequency so we can continue to use I2. If you want to change it, that's fine, right? But you have to use the appropriate periodic interest rate. Right. Okay. So first we're going to find present value 1. Let's do it by hand. Oh. Here on the test, if you prefer to use your calculator, that's fine, right? But I'm going to do it by hand. So payment amount times 1 minus 1 plus I to the negative n over I. $100, oops, times 1 minus 1 plus 0.00, what was it? 2501683. 2501683. Did I store that? I didn't. Did I even calculate it at all? I didn't. Oh well. I've got the other one. To the power of 26 over 12. Store that in 1 now. Great. Phew. To the power of negative 60 all over 0.00. 0.00250168.3. Yeah, you'll want to keep them straight. 1 plus recall 1 to the power of 60 negative. 1 minus that divided by recall 1 times 100. Why not? 5,564.957846. So PV1 is $5,564.96. So now, right, this is the same as the future value, right? This is the future value of PV2. Okay. So now we're back to just regular compound interest. Remember those days? Simpler times. PV2 is the future value over 1 plus I to the n. So now we've got a future value of 5,564.96 over 1 plus, remember I'm going to use that I2 that I found, right? Because the number of the number of compoundings that I calculated was using the payment frequency 12. Right? So as long as you've got your frequencies and your I's matching, it doesn't matter which ones you use, but they have to be matching. So 0.00250168.3 to the power of n, which I just had 48. One plus recall 1. Probably not. To the power of 48. And then 5,564.96 divided by that guy. I get 4,936.018203. So the value of this investment today is $4,936.02, rounding. The value of this investment today is $4,936.02. So if the bank said, hey, if you invest $4,500 today, we'll give you this offer, right? In 4 years, we'll start paying you $100 a month, right? For 5 years, you'd say, oh, okay, sure. Assuming that you have it laying around, right? Because it's actually worth $4,936, right? And so that's how we use that. Ooh. Any questions about that? Nice. So my favorite thing, 7.3, is perpetuities. Perpetual, forever, perpetuities means we have payments forever. Not making payments, but getting payments. So the idea is that we invest some amount, right? Has anyone heard of perpetuities before? They're really like a fun idea. So you invest some amount, right? Let's say you win the lottery. You invest your $1 million, let's say So this is probably why it's my favorite. Like, oh yeah, sounds great. Right, so you invest it, and at each compounding, you go in and you take the interest that you earned and you just skim it off the top. You've still got that million in there to earn the same amount of interest for the next compounding period. Then you go in, skim it off the top. So that million just stays steady forever, right? Until you dip into it, it's just going to stay a million. So for each compounding period, you swoop in, skim off the top, and then you move on, right? And so you can make investments and just, someone told me yesterday that I guess the maximum length of time that you can do it is actually 72 years, which is still pretty good. We will pretend that we can do it forever and ever and ever. It doesn't matter, okay? So the idea is we skim off the top and just kind of take out the interest that we've earned, right? But the principal stays the same throughout. So that's pretty fun. Do I like it because the formulas are really short? Yeah, there's probably that too. If you look at your formula sheet, right, you've got a present value of a perpetuity, meaning how much do you need to support a perpetuity with payments of whatever at a rate of whatever. Right, we'll go through examples. And then a perpetuity due, the only difference is you have to have that initial payment ready, and then it behaves the same way. Right. So, my favorite thing, perpetuities. So I just think of it as we skim the compound interest off the principal amount at each compounding to get payments forever. Woohoo. So we've got a present value of a perpetuity is the payment amount that you need or want or get, I guess. If you have some amount, you can figure out what payments you would get over I. So just little notes here. Or first, I'll just highlight that this is on your formula sheet. I guess I didn't do that for your annuities due, but I can go back into that. I don't even think I wrote them all out. Sloppy. Oh well, you have your formula sheet. So your present value of the perpetuity is going to be how much principal you need to sustain these payments. Okay. So how much principal you will need. The payment is the periodic payment we get. And I is the periodic interest rate. Periodic interest rate. Again, though, if interest is compounded annually and we want monthly payments coming out, of course we have to change our periodic interest rate. So we have to find I2 just like we did before, right? And so we might need to adjust the compoundings, to match the desired payment frequency. Desired payment frequency. Nice. Of course, if payments have to be made at the beginning of the payment period, right, you use due. So if payments need to come out at the beginning, of the payment period, we have to use the present value of a perpetuity due is again the PMT over I plus the PMT. And this is on your formula sheet, of course. And that last PMT is just because we need to have initial payment ready. Nice. Let's do example 232. It's a little bit sneaky because it's going to be a combination of a deferral and a perpetuity. Okay, so let's read it and talk about it. So a donation of $350,000 is made to support youth sports in Kelowna. How nice. In order to hire a part-time administrator, the organization requires $25,000 annually at the beginning of the year in perpetuity. So they require some amount, right? They know they have to pay this person $25,000 at the beginning of each year. How long should the organization invest the $350,000 for at a rate of 5.5% interest compounded semi-annually so that they can hire the administrator, right? So this $350,000 isn't necessarily just going to jump right in and pay off $25,000 a year, right? But we're going to invest it, let it grow until it can sustain those payments, right? So let's see here what we've got. So the payments that we're talking about are at the beginning of each year. So beginning, and the frequency is yearly, right, annually. And compound is semi-annually. So we can still jot those down. So we're in the beginning. And our payments per year is 1. And our compoundings per year is 2. This is the same as F1 and F2. Because these aren't the same, right? We're compounding semi-annually, but we only want to take out our amount. We only want to skim off the top once a year. So we have to make adjustments, right? Change our compounding to annually. R1 is 0.055. I1 is R1 over F1. 0.055 over 2. Oh, rats. 0.055 over 2. Yeah. 0.0275. Can find I2. 1 plus I1 over F1 over F2 minus 1. 1 plus 0.0275 over, or to the power of 2 over 1 minus 1. Plus 1 to the power of 2 over 1 minus 1. So we get 0.0557625. I better store that in 1. Now we can draw this out. Nice to get this out of the way. That'll just be default for all your annuities. Just gonna do that. That's a good chunk of work done. Then draw your timeline, get that under control. So what we've got is kind of a different situation, right? Because technically it's gonna go on forever. So I'll just do a little arrow, right? Because these payments, right, once they start, they don't stop. They go on in perpetuity. Perfect. So for some amount of time though, we don't know when we can start, right? But a year later, we'll be able to withdraw 25,000. So at this unknown start date, we'll be able to withdraw 25,000. At the year mark, we'll be able to withdraw 25,000. And let's go another one. 2-year mark, another 25,000. ... forever. Right? So if you've got a perpetuity, that's how you just show it. Just 1 or 2 ticks, and that's good enough. So these, up to this unknown time point, are going to be worth some present value of a perpetuity due. Just because that payment has to come out at the beginning of each year, right? So we've got a due. Same situation as before, except now we know that, okay, well, I'm starting with 350,000. How long is it going to take for it to grow to this amount? Right? So n equals, how long do we have to invest this to have some amount that's going to be able to sustain these payments? Seems reasonable enough. Okay, so finding the perpetuity, the present value of the perpetuity, that's not that bad. Present value of the perpetuity due is the payment amount that we need over I, which is just 25,000 over 0.00. Oh, just 1 0. 5575625. Good thing I stored that. So I have 25,000 that I need over recall 1. I would need 448,380.2264. So we would need 448,380 and 23 pennies to sustain these payments. Oh, I forgot. Eek. Eek. Good thing I've got you guys here to keep me honest. Plus 25,000. We need to have that first payment in there. I'll just fudge it. 473,380 and 23. Oops. To sustain these payments. Nice. We can find out, we'll just quickly wrap this up. We can find out how long it's going to take 350,000 to grow to 473,000, right? So now find how long it will take for 350,000 to grow to 473, 380, 23. Now you're back to just normal compound interest, right? Because there's no regular payments going on here. So you can use the N formula on your formula sheet. So N is the log of the future value over the present value over the log of 1 plus I. Remembering that if we use I2, which I'm going to do, right, then our compounding frequency would be 1, right, because that's the frequency of I2. So we have the log of 473, 380, 23 over 350,000 over the log of, oh, there we go. 1 plus 0.055, 75625. How about I just Martha Stewart this? 5.5654368889. It would take N equal to 6 compoundings. But N is time times the frequency. Use F2, right, as your frequency. So 6 is time times the frequency of F2 is 1. So time would be 6 years. Did it. See you guys on Thursday. Make sure you do the practice tests, right? Bare minimum for those completion marks is timelines for the long answers. Thursday, oh, the Moodle assignment's due on Friday night. The practice test is due in class at the beginning on Thursday. Nice. End meeting.